Hello guys, and welcome to the first of our notes. 1-1, apply properties of real numbers. Now, as you are starting to get used to this, hopefully it's rather easy to see what's going to be happening. Again, be sure you have a pencil, a pen, some different colors will help you out in the future. Make sure you have your little notebook next to you to write down any additional questions. You can either write them on here, but again, you want to bring your questions to class. So if you have any additional questions that you can't find elsewise online or in the textbook, bring them to class. Write them down. Other things, a calculator, which we've talked about, particularly not maybe in these earlier units, but just have that nearby. And again, these should not be taking too long. The great thing is that if it's going a little too fast, I'll try and keep my pace okay. You can go back and rewatch at your own pace. But hopefully this stuff right here is not too hard at all. I'm going to start into this semester rather easily. And just so we're all on the same page when we talk about things later, we're going to just talk about the properties and the types of real numbers. Now, the other thing is your essential question. Make sure you are responding, either writing it down or I believe I will allow you to just share it under the comments on the website, but you need to either have it written down or on the website if you can't do that. But again, we'll work through those bugs. Real numbers, let's get right to it. So for our class, all we are dealing with are what are known as real numbers. They're real, they're out there, they're ready to find you, and you can see them. They are any type of number, any number. That is the number sign, by the way. I know you know it as pound, but decimals, fractions, numbers that go on and on and on, so repeating. If you need some examples, we can have like 1/2, you can have 0.5, you can have 10, -30, etc. Those are all real numbers. But what we like to do with mathematics is we sometimes just want to talk about certain types. So this chart here splits up our real numbers. They're either going to be rational or irrational. That's the first step. So the first category. Category 1, either rational or irrational. If it's rational, it can't be irrational. If it's irrational, it can't be rational. Now, rational numbers simply means they can be expressed as a fraction. Can be a fraction. So that means we have numbers like 1/2, we have 0.5. 0.5 is a terminating decimal. We know that's also 1/2. You can have regular numbers like 1, 5. You can have negatives, -1, -5. Mix it up some, -1.2, 3, 4, 6. But it stops there. And the key thing is rational numbers, they can be a fraction and they must have a termination if they're a decimal, or terminator, or ending decimal. So notice the decimal stops, or the number stops, the decimal's here, the number stops right there. It doesn't keep going on forever and ever and ever. -1.2346 If you type that in your calculator and go to fraction, you will get the fraction. But rational numbers, fraction, terminating decimal. That's what makes them rational. Now, your decision is, well, if it can be a fraction and if it's a terminating decimal, then it's rational. To not be rational, okay, means it's irrational. So, I mean, pretty much common sense. So, irrational, use a different color here, means that it can not be a fraction, cannot be written as a fraction, and or it does not terminate. Does not. Whoops, sorry. It's okay. We're going to be back here in a second. Ooh. It's okay. And it does not end as a decimal. I'm sorry about that. If you got nauseated, take a deep breath. Let it out. Okay, so examples of these are numbers like pi. Pi is 3.14159, goes on forever. Okay, it's not rational. It's not that it's not real. Again, they are real numbers. They are just not rational. Okay, it goes on forever. It's out there. We can see it, but we don't have a definite answer as to what's going on. Other examples, there's a fancy letter E. That's a natural number, if you ever see it. It never ends. Or things like, let's see here. Those two numbers, decimals that don't repeat. They just can't be written as fractions. The other key thing are square roots of non-perfect squares. So square roots of non-perfect square numbers. So a square root of 2. Again, if you type these in your calculator, you get a decimal that never ends. Now, one note over here for rational numbers, again, I forgot to mention. Boop, boop, boop. Repeating decimals are rational. Okay, things like 1.3 repeating, because they can be, again, written as a fraction. So rational numbers, fraction, terminating decimal, repeating decimal. Okay, those three things. Irrational just means that it cannot be written as a fraction. Not be written as a fraction. Pi, fancy letters, and mainly square roots of non-perfect squares. Moving on. From rational numbers, we go to category 2. Integers. Now, integers, they are rational, and they are, more specifically, not fractions. Okay? But they are negative whole numbers, so negatives, 0, and positives. If we were to look at these numbers on a number line, you have big number line there. We have positives, so we have 2, we have 1, we have 0, we have -1, we have -2. Okay, no fractions, just mainly positives and negatives. And the last level we have are whole numbers. And these are numbers we can physically, I guess, see. You can like go to the grocery store and say, oh, I'm going to buy 1 box of cereal, things like that. Negatives, these are just 0 and also positive numbers. So we're kind of just whittling down the number line here starting at 0. You can have 1 box of cereal, you can have 2, you can have 3, you can have 4. But notice we do not have any of the negatives because you can't buy a negative box of cereal. So no negatives. Okay. Represented on a number line. This is basically all you're going to be asked to do is represent each of these on a number line. Again, the whole thing is real numbers. That's our little sign for reals. Okay. Things like irrational numbers, they might appear, but they're kind of hard to represent, so oftentimes we just kind of guesstimate as to where they are. But rational numbers, again, they are all your types of numbers along the line. And then we have integers. So integers are positives and negatives. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so all those would be integers. Let's see if we can get a different color here. Pen. Okay, so integers we'll say are red. Boop, boop, boop. And they're kind of going all through there. And then whole numbers we will say are green. And they are coming up here. Now, to be certain, whole numbers are still integers. Okay? So integers are a piece of the whole number spectrum. It's just this number here can go the whole way down. So classifying numbers, negative 20. Is it real? Yes, it is real. And we will talk about numbers that aren't real later on. But it's real. More specifically from there, it is rational. It's a fraction because it's really negative 20 over 1, which is a fraction. So it's rational. From there you decide, is it an integer? Well, yes, it's an integer because it's negative. And it's not a whole number. So it's not a whole number, no, because it is negative. Okay, easy peasy. Next one here, terminating decimal. Boop. Okay, so it's real. It is rational. And is it an integer? No, because it's a fraction. So you just stop at rational, okay? This is an integer. Whoops. Back. Go back. Where's my backspace? There it is. It's an integer, and this one is rational. So you would circle integer. You would say it's just a rational number. Okay? Go ahead and try these ones out on your own later on. Answers, I believe, are in the textbook if you're following along. Graphing them on a number line in increasing order, again, should be rather straightforward, I hope. Type into your calculator to get them all in the same form. So square root of 20, let's see, my calculator here is really about, clear that out, 4.472, and it goes on forever and ever and ever, okay? Negative 5/4. Again, type it in your calculator so you can kind of visually see what's going on. 1.25, terminating, negative of course, and then 12.5. So they're all in decimals. Plot yourself a 0. 4.412. Let's see here. 2, 4, 6, 8, 10, 12. Okay, and maybe 2. If you have to make your own number line, I won't be too picky on as to how you set it up. Make sure you do have 0 in there. 4.472. That's about, well, that'll be 5. So make sure you're writing square root of 20. It's not 4.472 terminating. It's the square root of 20. So it's about in there. Negative 1.25. Here would be negative 1, so it's a little bit more. Okay, negative 1.25. And 12.5, 12, say maybe here's 14, 13 and a half. Okay. The key thing is write down negative 20, square root of 20, and just take your time. Okay. Easy peasy points. We should say, thank you, Mr. D. Thank you. Okay? Easy peasy points right there. Now, the next piece is properties of real numbers. And again, this shouldn't take too long. So, you've seen these in the past, I believe. And what we're going to talk about are these different properties. Closure, commutative, associative, identity, inverse, and distributive. And we're just going to basically run down these. So closure, all it means is if you have addition of real numbers and you add two real numbers, so add or multiply reals means you get an answer of reals. Okay, reals in equals reals out. We don't really see this too much, so don't worry very much about like how it's represented, because it's kind of easy. It just means that a plus b is a real number. For A and B real. So if they're real numbers, then A and B are real numbers. Okay, multiplication A times B means you're going to get a real number, and again, that's if A and B are real. Okay? It's kind of like you and a friend. You're both real. If both of you go on a trip, it's not that one of you disappears completely. It's just closure. It means it didn't go anywhere. Okay? Commutative, this is more of the important ones here. Commutative is often thought of as variables commuting, variables or numbers moving or switching spots. Okay? And this can be seen as A plus B equals B plus A. Alright, they commute. So A goes the other side, B goes the other side. They just switch spots. So it's things like 5 plus X equals X plus 5. Okay? Same exact thing. But notice the numbers are switching. It's the variables and the numbers that are switching. Okay? So 5 plus X. Multiplication, same idea. A times B is equal to B times A. Oftentimes it's just AB equals BA. And if you need an example, 3x equals x times 3. 4xy equals 4yx. Okay. the number is the thing, or the variable is the thing changing. Associative is where it can get confused with commutative, and this is when you have parentheses, so that's kind of the big thing, parentheses, and it's what is grouped changes, so grouping changes. So for addition, if you have A plus B in a group and you add in C, it's the same thing as A plus B plus C. Okay, so if we're going out to eat, say, and Abby and Brian get there first, and then we'll say, I'm just throwing out names, Courtney comes along, and we're all at the restaurant, okay, it doesn't matter to the waitress, they still see that it is Abby. And then we'll say Brian and Courtney came along. Okay? So it's the same idea. Grouping is what changes, though. Again, multiplication, A, B, C. Parentheses are oftentimes, or grouping signs, what give it away. A times B times C is the same thing as first grouping, A times B times C. So 3xy equals, we'll say, 3xy. Same thing. Now, those two get confused a lot, so be careful. And these two get confused a lot. Identity and inverse. Identity basically means you get the same exact number as a result. So the same number is your result. Inverse, we're going to talk about, you get a different number as a result. Now, it looks different for all these cases with addition and multiplication. So the additive identity. Well, what can you add to any number to get that same number? It's 0. 3 plus 0 equals 3. Same number in, same number out. X plus 0 equals x. Same number in, same number out. Multiplication, the identity, you guys probably know, is 1. 3 times 1 equals 3. And x times 1 equals x. You get the same number out. Now, when we start talking about inverses, the additive inverse is the opposite. Okay? So here's what we mean. We get a different number as the result. And we're going to, if it's addition, get the additive inverse. So 3 plus negative 3. That is the opposite, equals 0. Notice, we start with a 3. We end with a 0. That makes it inverse. X plus negative x equals 0. Start with x, we get 0. The multiplicative inverse is the reciprocal. Okay, which is a fraction flipped over itself. That word should seem familiar. So if we have 3 and we multiply it by 1/3, reciprocal means fraction flipped, you get 1. Again, start with one number, end with another. Now, what if we have 2 over 5? Okay, you would multiply by the reciprocal, just positive 5 halves, and get 1. So you start with 2/5, you end with 1. It's different. Okay, multiplicative inverse, reciprocal, additive inverse, opposite number. Almost done here. Distributive is the last property we got, and it simply states you can distribute to multiplication. So distribute multiplication distributed to a quantity. So what do we mean by that there? If you have A times some quantity B plus C, it's the same thing as AB plus AC. Here is the biggest thing, okay? This is certainly true. Now, we can reverse this. So, if you have AB plus AC, you can undistribute to A, B plus C. So it goes both ways. We're going to be practicing with that specifically in class. Distributive for multiplications, it's really the same idea. Let's just put some examples up here. So 3 times the quantity x plus y equals 3x plus 3y. Now, this other version means if we have 4a plus 4b, really, we can take that 4, they each share it, and have a plus b. So notice, everything shares this 4. So we can bring it out. Alright, everything here shared a. So we can bring it out. It's just the opposite of distributing. Okay? But we will be practicing with that. So, division and subtraction, you can think about these on your own perhaps. Subtraction is really adding the opposite. And division is really multiplying by the reciprocal. Okay? I promised I would narrow it down to about 30 minutes, and that's about where we're at, and it's perfect. So what I'd like you to do is, again, look back through, write down your questions, and we will be tackling some of these problems tomorrow in class. So feel free to look through, identify the property that each states. Again, I believe these are in the textbook, but do your best, but at least have those notes down. Now, be sure, again, get that essential question, write it down, write it out, or share. Okay? So come tomorrow being aware of these properties. We're going to be using them, practicing them, and that's all I got for you today. So awesome, awesome stuff. Hope it wasn't too bad. 29 to 30 seconds. That's about all it took. So awesome, guys. Thanks. And we'll see you tomorrow in class.